Hello students, hope you're all doing well. Welcome to another video by QuickStudy. Today we will start another topic of GCSE Physics, and our topic for today will be momentum. The picture you see here is a Newton's cradle. It is a device which Newton used to prove his laws. Let's see how it works. To see how Newton's cradle works, we have to pull one of the balls at the left end to a certain height and then release it. See, that ball which we released will now collide with the other balls, and the ball at the far right end will reach the same height as the ball we pulled. Let's see the cycle we have created now. Each time one ball at the left end hits the other ball, the height to which the left ball was pulled in the beginning, the right ball will reach at the same height. This is how a Newton's cradle works, and this proves one of Newton's fundamental laws, which we will study now. Before we get into the Newton's law, we have to know about our topic for today, which is momentum. Momentum is a quantity possessed by masses when they are in motion. Momentum is a measure of how difficult it is to stop something that is moving. We calculate momentum of a moving object by using the equation momentum is equal to mass multiplied by velocity. In short terms, for the sign of momentum is used as rho. It is very similar looking to P, but it is not. So rho is equal to mass multiplied by velocity. Momentum is a vector quantity, and it is measured in kilograms meter per second, provided that mass here is calculated in kg and velocity is calculated in meter per second. But remember that this is not the only formula we will need. There is another formula which we will use more than the base formula of momentum when we will be working with collisions. The formula which we will use while working with two objects colliding is known as the conservation of momentum, or the law of conservation of momentum. It basically states that momentum before the collision is the same as the momentum after the collision. We have already seen this in the Newton's cradle, where the ball after hitting the other balls will reach the same height as before the collision and after the collision. So the formula would be m1 into u1 plus m2 u2 is equal to momentum after the collision, which is m1 into v1 plus m2 into v2. Here m1 is the mass of first object and m2 is the mass of second object. u1 is the initial velocity of the first object and u2 is the initial velocity of the second object. v1 in the same way is the final velocity of the first object and v2 is the final velocity of the second object. I know all of this must sound very overwhelming. Let's look at an example to make it easier. Before we go there, let's remember when an object is not moving, the velocity will be 0, and when an object after hitting something stops, the final velocity will also be 0. A railway truck with a mass of 5000 kg rolling at 3 meter per second collides with a stationary truck of mass 10,000 kg. The trucks join together after collision. Note here, as they are joining together, their masses and velocity will be singular. At what speed do they move after the collision? We shall assume that friction forces are small enough to ignore, so we can apply the law of conservation of momentum. We know that the momentum of A before collision plus momentum of B before collision is equal to momentum of A and B moving together after the collision. So the formula would be m1 into u plus m2. Here u2 would be taken as 0 as the second truck was not moving, is equal to m1 plus m2 into v, as the velocity will be singular, where m1 is the mass of a truck A, u is the velocity before the collision, m2 is the mass of the truck B at rest before the collision, so its velocity is 0 as we have discussed, and v is the velocity of the two trucks after the collision. So substituting these values gives us 5000 into 3 plus 10,000 into 0, which would be 0, is equal to 5000 plus 10,000 multiplied by v. We have to calculate this v. So v would be equal to 15,000 divided by 15,000. So the answer would be 1 meter per second as we're calculating the velocity. After the collisions, the truck moved with a velocity of 1 meter per second in the same direction that the original truck was traveling. So I hope this example makes it easier for us to understand. In IGCSE, we will mainly work with the 3 laws of Newton, and we will start from the last, which is the Newton's third law of motion. In simple language, it might be stated as when we push something, it pushes us back just as hard, but in the opposite direction. It is usually stated as for every action, there is an equal and opposite reaction. When we sit down, the sit also pushes us back in the upward direction with the same force. For example, if I'm pushing a table with a force of 5 Newton, the table is also pushing me, but in the opposite direction with a 5 newtons of force. Let's look at an example here. In this figure, there are two people with roller skates. Person X is clearly pushing person Y, but it is not obvious that person Y is also pushing X back. When X and Y move, it is clear that X has been affected by a force pushing him to the left. The force felt by X is the reaction force. So students, we have now learned how a Newton's cradle is used, what is momentum, what is the conservation of momentum, and about Newton's third law of motion. That's all for today, students. Stay with us to learn more about physics and other courses as we post regularly on our channel. To learn more about our online tutoring service, do visit www.quickstudy.uk.